What's up? Today we're going to be talking about speed. What I want you to do first is look down at the right hand side of the screen and look at that little triangle down there. Alright? We're going to be using this today to solve for speed. Alright? So the first thing I want you to understand is the V on there stands for velocity or speed. And our units when we talk about that are going to be in meters per second for the most part. It might change. We might use miles per second. We might use miles per hour. This is the metric system. Standard form. One other thing I'm going to point out, velocity is speed in a given direction. Speed is just distance in a certain amount of time. Alright, so that's the difference between them, but they're both the measurements of the same thing. Just velocity has direction along with it. So V can either stand for speed or velocity. Next one, D stands for distance traveled. For the most part it'll be done in meters, but that's not always the case. And finally, the T stands for time taken, and it's going to be represented by seconds for the most part, but that's not always the case as well. Okay, now to show you how it works. So, if I know distance and time, D and T, alright, my formula will be D divided by T to equal V, and V is velocity. So if I know D and T, then obviously I don't know V, and I need to solve for that one. That's what the equation gives you, velocity or speed. Alright, let's do another one. If I have speed and time, I don't have distance, so I'm solving for distance, so it's going to be velocity times time equals distance. So V times T equals D. D stands for distance. Alright, let's do our last one. We have distance and speed. So if we have distance and we have speed, then we don't have time. So we're solving for time. So it's going to be D over V equals T, or D divided by V equals T. Okay? And T stands for time. Alright, let's do a problem. Jay walks to school at a speed of 4 miles per hour. If it takes him 30 minutes to walk from home to school, how many miles away is the school from his house? Alright, let's talk about what we know in here. We know that he travels 4 miles per hour, and that's speed, or velocity. And we know that he it takes him 30 minutes. That's time. Alright? Before we plug this into the equation, though, we're dealing with hours and minutes here, so they're not the same unit. So we're going to have to use factor label method to get them to the same thing. So let's do that first. So to do that, I'm going to put 30 minutes over 1, I'm going to make it a fraction, and then we'll multiply it by 1 hour over 60 minutes, because there are 60 minutes in 1 hour. When I do that, I can cross out my minutes, alright, and then when I multiply that, I will get 30 over 60, okay? Now, I need to divide these to get these to a decimal so I can work with it. So it's going to be 30 divided by 60. That's going to give me 0.5, and my hours will carry over, so it's 0.5 hours. All right? Now that I have that in decimal form and it's been factor label methoded, let's plug it into our formula and solve for it. So it's going to be 4 miles per hour times 0.5 hours, and that will give me 2 miles. All right? Let's do another one. That was pretty simple. Alright, so recently the speed limit between Park Hills and Farmington has been raised from 60 miles per hour to 65 miles per hour. If the distance between the two cities is 18 miles, how many minutes are saved by traveling at the new speed limit? First thing we notice is that 60 miles per hour. Alright, that's one of our given, and that is velocity. There's two of them. Okay? The next thing we need to look at is 18 miles per hour, or 18 miles, not per hour, 18 miles. That is going to be our distance, alright? So it's going to be distance divided by velocity to give us time. One other thing I'd like to point out is that time over here is in minutes. So we're going to have to convert our hours to minutes, okay? Let's do this. So I'm going to take 18 miles. So that's the distance. It's going to be on the top. And underneath that is going to be our velocity. And we're going to go with 60 first. So 60 miles per hour. Alright? Because I have miles down here and miles over here, they both cross out. And that leaves me with hours. If I divide 18 by 60, that gives me 0.3 hours. Okay? But I'm not done because I got to take that to minutes. So I'm going to put that over 1. I'm going to do my factor label stuff now. I'm going to times it by 16 minutes over 1 hour. And I'll be able to cross out the 2 hours, leaving me with minutes. And when I times 0.3 by 60, that gives me 18 minutes. Alright? That's the first one. Now we need to do the same thing because we have 65. We need to find the difference. So we're going to subtract these two once we solve for their times. So it's going to be 18 miles over 65. Once again, my miles cross out. And when I divide 18 by 65, that gives me 0.27 hours. I'm going to put that over 1 once again, and I'm going to multiply it by 60 over 1 hour. Now my hours will cross out, and I'll be left with minutes. And when I do 0.27 times 60, that gives me 16 minutes. All right. Next thing I'm going to do is I'm going to subtract those. So 18 subtracted from 16 gives you 2 minutes. All right, and that's your answer for that one. Let's do one more. So you need to get to class 300 meters away, and you can only travel in the hallways at about 2 meters per second. How much time will it take you to get to your class? Okay, let's solve this. We know that 300 meters, that's going to be distance, and we know that 2 meters per second is going to be velocity or speed. Okay, so we were going to divide those two to get the time. All right. So 300 meters over 2 meters per second, and my meters will cross each other out, leaving me with just seconds. And when I divide 2 by 300, that gives me 150 seconds. And that's the answer for that one. Last thing we need to look at is looking at graphs when it comes to speed. So we're looking at a plane trip here. And the plane traveled for 7 hours, and it reached a top. It traveled around 1,200 miles or kilometers. I'm sorry, kilometers. What is the average velocity of the plane between 5 and 6 hours? So over here, it'd be 5 hours. I would say it was at 650, and over here at 6, I would say it's at 800. So I'd take 800 subtracted by 650. All right. And then, because it's only 1 hour difference, I would divide that by 1. Now, if it was between 4 and 6, that number down here would be a 2. But since it's only between 5 and 6, and it's only 1 hour. All right? So when I do that, I come up with an answer of 150 kilometers per hour. All right? Let's do another one. How far does the plane travel between 0 and 2 hours? Well, that's a pretty simple one. I look here at 2. I come up. It's 400 kilometers. Simple enough. It's also at a constant, so that lets you know. Our last one. What is the velocity of the plane 7 hours after takeoff? So you look down here at 7 hours. You traveled for 1,200. So it would be 1,200 kilometers divided by 7. All right, and that's going to give you 171.4 kilometers per hour. All right, guys, I hope this helped you. Any parts you didn't get, go back, rewatch it. If you didn't understand factor label method, once again, go back and rewatch that one.